Welcome to week 6 of summer and what for a lot of you will be your favorite week of summer math because it's pretty dang understandable and it's pretty quick. So some of this was alluded to in tutorials. If you did tutoring with me last week, we did a problem similar to this. And now we're just going to add a couple more components. The deal is we're talking about piecewise functions. And a piecewise function is, of course, it's a function made up of pieces of other parent functions. And so in your notes guide here, the first one that you see, I've given you both the equation and how it's written and the graph that goes with that. So let's talk a little bit about that before we jump right into the stuff below. If it's a piecewise function, you will see a function name, f or g or h. Then you will see this funky bracket, okay? And what that bracket is doing is it's letting you know that more than one equation define the function. So if you'll notice, it's got a line here. X plus 3 is just a linear equation. And if we graphed x plus 3, we would start at 3, and then we would do our slope, and it would look something like this. Now, what has happened here is that this green part has been erased because always behind the function you will see it's called a domain restriction is what this is called. All of this back here is called the domain restriction. And what it's doing is for each equation, it's restricting your graph so that it can only exist at these points. So for this line that I've graphed in green, it says, oh wait, I only want to see it when x is less than -1. So they went to x less than -1 and they kept everything that's less than that, but they erased everything greater than that. Now, why the open circle? Well, the open circle has to do with the symbol that's in the problem. If it's strictly less than or strictly greater than, you will always see an open circle. And if it's less than or equal to or greater than or equal to, you do get to fill in that circle. Okay, so hopefully this makes sense. The first one's a line, the second one's a parabola. So here's that parabola, and it's been erased everywhere except between x is -1 and x is 2. So here's x -1, here's x2, and it kept everything in between that, and it erased the rest. And then we want to graph the line 3, which is just a horizontal line, if x is bigger than 2, and that's what you're seeing here. Okay, so you are going to be asked all kinds of good stuff, and that's what these boxes down here are going to help us with. The most important thing that teachers are going to start with is function value. Function value is where the point exists, okay? So where your point exists. And the way it's going to be phrased is something like f of something is equal to something. So what's going to happen is it will look like this. And if they are asking for f of something, like let's say they're saying f of 0, okay, then in words, what this is saying is what is the y value when x is 0? And how do I know it's when x is 0? Well, normally this is f of x, remember? F of x. So this value is always an x value. So to get that, you have two options. You can either look at your picture and go to where x is 0 and ask yourself, okay, when x is 0, what is the y right here? Well, the y just happens to also be 0 on this problem. Another option that you have is to take that 0, go up to the top, like let's pretend this wasn't graphed for you. You could go up to the top and look at your 3 equations. And what you would be doing, guys, is you'd be looking at these 3 equations and you would ask yourself, okay, x is 0. So if x is 0, where does 0 fit in this equation, this one, or this one? So in other words, is 0 less than -1? Well, no, it's not, okay? Is 0 between -1 and 2? And you'd be like, yes, yes it is. So if 0's between these two numbers, then that would tell you to use this equation plug your 0 in, so 0 squared is 0, and you can get it that way. I prefer this way. I know you're thinking that was a gigantic waste of my time. Okay, it's not, and here's why. Sometimes these are funky fractions, and there is no way that you'd be able to figure it out unless you had the equation. So let me give you one of those just to prove to you what I'm talking about here. Let's go with, all right, let's go with f of negative 1.5. F of negative 1.5. Okay, so if somebody asked me for f of negative 1.5, if you wanted to do the graphical approach, then you would come over here to negative 1.5 on the x, which is about right here. Then you would have to go up to your graph, which is about one here. It's about right here. And then you'd have to look over and ask yourself, what is the y value there? Okay, I don't know. It looks like it's like a little past 1.5, but it's hard to tell. And so because of that reason, gang, we're going to go back to the top and use our equation instead. So this is a bad idea if it's going to be a fraction. So negative 1.5. Okay, when I come up here, where does negative 1.5 fit? Is negative 1.5 larger than 2? No. Is negative 1.5 between these two numbers? No. Is negative 1.5 less than negative 1? Yes, it is. So this is the equation I look at. This is the equation that I plug in a negative 1.5 in the place of x. So that's the math that I do, and it turns out to actually be exactly 1.5. So you get the idea, I hope. You could use the graph or the equation. The equation's going to be way more absolute. Okay? All right, cool. So that's what you could be asked. Oh, one other one that's kind of a trick one. What if I had said f of negative 1? This tricks people in my class all the time. If you go to your graph on f of negative 1, well, negative 1 is like right here and right here. So the question is, which one is the answer? Okay. Well, the answer is always going to be the filled in hole. This is the answer. If the hole's filled in, it means you can exist there. And if it's a hole, you can't actually land on it. So the answer for f of negative 1 would just be the y value of 1. Okay. So that's an interesting little FYI. All right, so domain and range. That's another thing you might be asked. And on this one, it's a little tricky sometimes. You have to look at the graph as a whole and try to figure out all three pieces together, like this whole picture together, what is the domain? So what I do is I always start on the far left, which this one keeps going down. You can kind of see it got cut off, but this is going to keep going down and to the left for forever. So this graph definitely starts at negative infinity, and I'm going to use interval notation here. I've already shown some of you guys interval notation. Interval notation just says that you need to put where your graph's going to the left, comma, where your graph's going to the right, and you can either use parentheses or brackets depending on whether or not you land on something, okay? Well, for me on domain, to the left, it goes all the way out to negative infinity. And then what I need to look for is there any place that domain skips or stops? So like if you look at this piece, okay, good, we exist. Even right here at the funky jump, we still exist. Here, my x's are graphed. Okay, what about this funky jump spot? Well, this funky jump, the x's still exist because this hole covers up, the filled in circle covers up this hole, and then it keeps going. So there's no gaps as you look at this graph horizontally. And since there's no gaps, it's going to do all the way over to infinity. If there had been like a big old gap in the graph, like maybe it stopped here and then it picked back up over here, then you would have a two-part domain. You'd have a domain for this piece, then you'd have to do a U and a domain to pick up that other piece, okay? And the U means union with. I'm not sure if that's going to happen in your homework or not, but if it does, we'll go over it in the solutions video. Okay, range, same thing. Now on your range, instead of left to right, you need to look bottom to top and figure out what's the lowest value it can be, what's the highest value it can be. Well, on this one, once again, this arrowhead is continually going down, 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 okay? Which means the lowest value here is going to be negative infinity. And then as far as the top goes, you need to ask yourself what's the highest value. And as you're doing this, you also want to look along top to bottom and make sure all your y's are covered. So even though there's a gap here in the y-axis, there's not really, because there's y's here and there's y's here. So that gap's not really a gap because it gets covered up by those points. Same thing here. There's a gap in y's here, but there's all these y's right there that cover it up, so you're fine. The highest value on this looks like it's right here at a positive 4. Now, see how that circle's filled in? That's going to make me change something on my interval notation, okay? 4 is the absolute highest value, but I don't like that parenthesis. If you can land on the value, you use a bracket instead of a parenthesis. So that's how my range category that you could be asked is for where the graph is increasing, decreasing, or constant. And this is going to be exactly what you think it is when you look up here, okay? The only thing is the tricky part is like how to answer the question, okay? I guess I should leave that, okay. So increasing, this would mean like when you read a graph left to right, just like you're reading a book, then when is the graph increasing or going up? So as you go left to right, it's definitely increasing from here to here. This looks like it's going down, so I would not call that increasing. I'd call that decreasing. But then right here at 0, it starts to go back up. So that would be increasing again. And this guy over here, this is neither increasing nor decreasing, and that's what they call constant. So if I gave you a highlighter, I think a lot of people are good at increasing versus decreasing versus constant, but it's how to answer the question. You want to answer this almost like domain. You want to answer using your x values, okay? So I'm going to put right here, use x values to answer. And I'm also going to use interval notation. So for increasing, my x value furthest to the left would be negative infinity. And then it would go all the way up to this point right here, which is not 2. Look at the x value. It's when x is negative 1. Now I'm going to put a parenthesis on that because this is an open circle. Okay, so you only use those brackets whenever it's a closed-in circle, okay? Now, there's another place where this is increasing because the increasing is yellow, so I'm going to put U for union with. It starts again at 0, and then it goes all the way up to the top there when x is 2, okay? Now, what I'm about to do, this is going to be a teacher discretion. I'm going to put a parenthesis. There are some teachers that would have you put a bracket because that is a filled-in circle. But most teachers that have an actual math degree are going to say use parentheses everywhere. And it's going to be a real technical reason. It's going to be because if you are increasing, when you get to the top of that hill, whether it's a filled-in circle or an open circle, at that exact moment in time, you are doing nothing. You're not increasing, you're not decreasing, you're not constant. You're frozen, and so therefore you don't have movement, and so we say parenthesis because you're technically not increasing. So that's just a matter of preference, and I prefer parentheses everywhere when you're doing increasing, decreasing, constant. So decreasing is the blue, so what x values is that? That would be from negative 1 to 0. So that's what I'll put here, negative 1 to 0. And the constant interval is that green line, which goes from 2 all the way out to forever, because there should be an arrow on that. So 2 comma infinity. So I'm giving all of my answers in terms of their x value, and I like to use parentheses on all, but like I said, some of your teachers might let you do brackets on the ones that are filled in circles. Alright, cool. So that's pretty much all I have. Try those practice problems. And an extra challenge is for those of you that are going into pre-AP Algebra 2, okay? I've given you equations on the practice problems, not equations, sorry. I've given you graphs on the practice problems with no equations. It would be awesome if you have time to try to write the equation that goes with the picture, okay? One of them's way harder than the other, but I think the first one you could probably do. So that is something that I'll probably show you the answer in my video for, even though it's not asked, just so you can see if you did that right. Alright, thanks guys.